The way to find oblique asymptotes is usually long division, sometimes short division, but it's always division of some kind. Now, we've got two shortcuts in this problem. When you see a power on the top of the fraction that's way bigger than the bottom, not just one bigger, but way bigger, like x cubed over x, that's super top heavy. We don't do it. Okay, that's not a slanted asymptote. It's just something else. It's a curvy asymptote. And likewise, on the bottom of this thing, when you see equal exponents, x squared over x squared, equal weight. Cross them out. Doesn't happen. Even if that was 5x squared over x squared, that would also be equal weight because it's the exponents that I care about. Now, those out of the way, we're moving on to doing some actual division with the top-heavy examples. So in this case, I'm going to have 2x plus 3 on the bottom of my division, and I have 4x squared minus 7x minus 15. And the first thing I do is divide. Okay, so we're going to say 4x squared over 2x. That makes 2x. And the next thing I'm going to do is multiply. So 2x times 2x makes 4x squared. 2x times 3 makes 6x. Then we subtract. Okay, that's the last step. Subtract. And that's going to give me 0 minus 13x. Well, that's ugly. Carry down the negative 15 and then repeat. Okay, so you do some division. Negative 13 divided by 2 is negative 13 over 2. Stop here. We don't care about the remainder, which means there's no need to go any further with this. That right there is our quotient. Okay, so we say y equals, I'll bet you need to say y equals 2x minus 13 over 2. Now, if you want to find the remainder, go ahead. It doesn't matter. We don't need those for the oblique asymptote. Next one. I don't know if we'll have time to get through this, but here's how you would set it up. This is, let me do it a different color just so we don't get our boxes confused here. This is going to be x squared plus x minus 12 divided by negative x cubed plus x squared minus 2x plus 5. Okay, now I do my division first, and I get negative x. Then I multiply it back down. I get negative x cubed, negative x squared, positive 12x, and I do the subtraction. Okay, so this is going to turn into 0, and then I get, let's see, careful with the plus and minus signs. This is going to be positive 2x squared. And then negative 2 minus 12 is negative 14x, and I carry down the 5. Okay, so repeat. We start with division, and we get 2x squared divided by x squared equals 2. And then stop right here. That's as far as we need to go. We don't care about the remainder. That is what we put in. Negative x plus 2. Okay, y equals. All right, that's the hard part, the long division stuff. This one's nice. This is just synthetic division, right? When you have something on the denominator that's just a simple little x plus 1 or x plus 4, those are easy style. They don't have 2 in front of the x. They don't have any squares going on. So all you do is you set up your synthetic division bar using the root from the bottom, or the domain restriction if you like to think about it that way, and the coefficients from the top, like I have it here. Now we add down 2, and we multiply back up. So negative 2. Add down, we get negative 1. Multiply back up. And when I say multiply back up, I'm taking the negative 1 times the negative 1. Okay? So negative 1 times negative 1 is positive 1. And then we add down. Okay? So that's going to give me negative 2. Now, I don't care about that negative 2 right there. That's my remainder again. The part I care about is right here. That's my equation. So I'm going to say, let's see, where are we over here? I'm going to say y equals 2x minus 1. And you would repeat it exactly the same way with this last problem right here. Okay? Anytime you have a nice little denominator, that's synthetic division. We like that.